By mid-2026, the AI tools available to engineers have consolidated into a highly specific toolkit. We have moved far beyond a single generic chat window. Today, your choice of software depends on the mechanical or thermal problems sitting on your desk. The experimental phase has settled, and engineering teams are now building curated 3 to 4 tool stacks rather than chasing every new software release. What defines these mature platforms is their deep access to engineering context. They actively process the physical parameters of the parts you are designing. Extended thinking modes in general language models are excellent at stepping through a complex thermodynamic cycle, but they lack native awareness of 3D geometry or physical boundary conditions. To be genuinely useful, the most capable tools now read native CAD files directly. They understand dimensions, mates, tolerances, and how entire assemblies fit together. Without that structural and spatial context, a digital analysis is just a string of numbers. It cannot be accurately translated into a real manufactured object. The value of any AI tool is measured by how seamlessly it bridges that gap, taking you from a digital simulation to a functional prototype. CAD-aware assistants handle this gap by reading native geometry. They pull data directly from product lifecycle management systems to understand the exact constraints of your design file. When you input loading conditions and manufacturing limits, generative design features automatically propose structural geometries. What used to take days of manual iteration now gives you a full suite of options in a few minutes. This animated diagram demonstrates how specialized implicit modeling environments handle complex internals that conventional CAD struggles with. They can dynamically adapt internal struts in complex designs, like variable density lattices built for thermal management and heat exchangers. This capability heavily accelerates the design timeline. The engineer's role shifts from manually constructing geometry to reviewing load paths and selecting the optimal structure. Moving from geometry to logic, general-purpose models have become incredibly reliable at drafting Python scripts for your daily simulation automation. But code generation is different from regulatory compliance. Specialized tools now search directly through long technical standards. Exact page citations are critical because hallucinations on numerical constants remain a severe risk, meaning every output requires independent confirmation. The ability to cite a specific page is what empowers you to open the original standard, check the reference yourself, and confidently verify the interpretation. The stakes are high when applying fluid mechanics and thermal analysis to physical infrastructure, like the cooling systems managing massive server loads. To explore variance quickly, simulation surrogate platforms train on an organization's past data. They predict physics outcomes for new designs without running a full, time-consuming solver. This scatterplot shows a crucial safeguard known as a confidence metric. It acts as a strict boundary, instantly warning you if a query geometry moves outside the training data, where the prediction might become unreliable. When you respect those metrics, these surrogate models safely accelerate early-stage design exploration and filtering by over 100 times. The clearest near-term trend is the integration of these features directly into the software you already use daily. They are becoming native elements of product data management, CAD, and simulation packages. You can also deploy custom assistants across your team, preloading them with internal company templates, exact material databases, and specific calculation standards. Embedding these tools straight into the workflow applies context consistently, ensuring that critical institutional knowledge remains intact even when senior staff leave. Ultimately, any AI integration is only as effective as its underlying model and the engineering context it can access. The engineers who compound their advantage over time are the ones who build daily habits of critical review, treating the AI as an assistant that requires independent confirmation at every step. To learn how to build and verify your own curated engineering stack, visit ProBettyEngineer.com.